Hi everybody, welcome to the Unit 1 review. The first section says to solve for the variable. So remember, when we're solving, we are trying to isolate our variable. We are trying to get this variable by itself, and we have to use inverse operations to do this. So the first thing that I see is a plus 2. I'm going to do the opposite of adding, which is subtraction, and I'm going to minus 2 from both sides. A positive 2 and a negative 2 make 0, so those are going to cancel each other out. Plus 2 minus 2 is 0. So on the left, I'm left with 9x equals, and then on the right, 47 minus 2 is 45. Next thing that I see is a 9x. When I see a number and a letter next to each other, that is multiplication. So the opposite of multiplication is division, and we're going to divide both sides by 9. 9 divided by 9 is 1, so x equals 45 divided by 9 is 5. To check our answer, we can always plug that number back in. 9 times 5 plus 2 equals 47. That's what we're going to test out. This is called substitution. If x equals 5, I'm taking that x and I'm substituting in a 5. 9 times 5, of course, is 45. And 45 plus 2 is 47. Okay, over on number 2. Again, I'm going to get rid of my addition and subtraction first. So I have a minus 5. I need to do the opposite, which is plus 5. Negative 5 plus 5 is 0. Be careful right here. That 15x is negative. And 10 plus 5 is 15 as well. I see a number, the coefficient, and my variable x are touching. They're right next to each other. That means multiplication. So I'm going to do the opposite, which is divide, and I'm going to divide both sides by negative 15. A positive divided by a negative is negative. So my answer is negative 1. Again, I can check it by substitution. Take that negative 1 and put it right in here for x. So negative 5 minus 15 times negative 1 should equal 10. Negative 15 times negative 1, a negative times a negative is a positive, and negative 5 plus 15 is 10. Perfect, it works. Okay, moving down to number 3. I have variables on both sides of the equal sign. So what I'm going to do first is I'm going to combine my like terms on the left and combine my like terms on the right. So I see my like terms are 11 and negative 7. Those are both constants, and 11 minus 7 is 4. Then on the right side, I have a 6x and a negative 3x, which are like terms. 6x minus 3x is 3x. Now you might notice something a little bit weird right here is that I have 3x and 3x, which are the same, and then I have 4 and 5, which are not the same. So whenever I am solving equations with variables on the both sides, it doesn't matter where I move the x's and where I move the constants, but I need constants on one side, I need x on the other side. So I'll subtract 3x because I'm doing the opposite of adding. And what happens here is that 3x minus 3x is actually 0. And 3x minus 3x again is 0. I'm left with 4 equals 5, which it doesn't. And this would make our answer no solution. Our variables completely went away. 3x minus 3x is 0. 0x. Completely gone. Okay, over here, we have variables on both sides. We do not have any like terms to combine. We have our 5n, we have our constant 34. We have our constant negative 2, we have our 14n. So we can go straight to moving our n's to one side, moving our constants to the other side. Variables on one side, constants on the other. I like to keep my variable coefficient positive, so I'm going to subtract 5n from both sides. 5n minus 5n is 0. So I'm left with 34 equals negative 2, and then 14n minus 5n would give me, whoopsies, 9n. Since I have my variables together on the right, I'm going to make it so my constants, just my numbers, are on the left. So I'm going to do the opposite of minus 2, which is add 2. Negative 2 plus 2 again is 0, and this gives me 36 equals 9n. I see my number and my variable are touching, they're multiplying, and the opposite of multiplication is division. So I divide both sides by 9. 9 divided by 9 is 1, and 36 divided by 9 is 4. Checking my answer, plugging it back in. Substitution here and here. 5 times 4 plus 34. 20 plus 34. Remember our order of operations, PEMDAS. Multiply before you add. 20 plus 34 is 54. Okay, I'm going to check out the other side. Putting my 4 in for n. Negative 2 plus 14 times 4. 14 times 4 is 56. And negative 2 plus 56 is 54. It works. Substitution. Okay. Again, combining some like terms. We have the 3x and the negative 7x. 3x minus 7x is negative 4x. Variables on one side, numbers on the other side. Which side, it doesn't matter. One side must be the variable, one side must be your constants. So let's add 49 to both sides. Negative 49 plus 49 is 0. So we're left with negative 4x equals 84. The negative 4 and the x are touching, they are multiplying, so let's do the opposite. Divide by negative 4, divide by negative 4. A positive divided by a negative is negative, and 84 divided by 4 is negative 21. Again, we can check it. Substitution, plugging in for here, x, and there for x. So 3 times negative 21 minus 7 times negative 21 minus 49 equals 35. All right, let's check it out. 3 times negative 21 is negative 63. A negative 7 times a negative 21 is going to be positive 147, and then minus 49 needs to equal 35. All right, let's check this out. Okay, negative 63 plus 147 is 84. Oops. And 84 minus 49 is 35. Perfect. All right, next one. We have some like terms again, and we have variables on both sides. So let's combine our like terms. 5d minus 4d is just 1d. Again, I like to keep my variables positive. I like to keep those coefficients positive, so I'm going to add 5d to both sides. Negative 5d plus 5d is 0. D plus 5d is 6d. Since I have my variables on the left, I'm going to move my constants, my numbers, to the right. So plus 9 and minus 9 are going to cancel each other out. So I subtract 9 on both sides. 51 minus 9 is 42. 6 and d are multiplying, so I will divide. And 42 divided by 6 is 7. Let me get my calculator up so I can show you. how we can check this using our calculator. So my original problem was 5d plus 9 minus 4d equals 51 minus 5d. So I'm going to use substitution. My answer was 7, remember. 5d, but I'm going to put a 7, substitution, plus 9, then it was minus 4d, but d was 7, okay, 16. The other side should match. It was 51 minus 5d, so 51 minus 5d is 7. There we go. Both sides are equal. That's how we can use our calculator. So I was just plugging in for d, plugging in for d. Substitution. All right, we got 2 more. Ooh, distributive property. When we see a number, a constant, in front of these parentheses, we need to multiply by all the terms that are inside. So distribute, distribute. Negative 3x. Now when we distribute, we have negative 5 times negative 2x. That would be positive 10x. Then we have negative 5 times negative 16, positive 80, equals 31. Combine our like terms. We have negative 3x and 10x. That's 7x. We've got to move those constants to the right. Minus 80, minus 80. 7x equals negative 49. 31 minus 80 is negative 49. We see that 7 and x are touching. They're multiplying. The opposite is division. 7 divided by 7 is 1. And x equals negative 7. I'll show you how to use the calculator on this one too. Why don't I keep it like this so I can actually see the problem. Hold on one second. Okay, that's better. All right, we're going to use substitution. X is negative 7. Negative 3 negative, what are you doing? There we go. Negative 3 times x, which was negative 7, minus 5, parentheses, negative 2 times x, which is negative 7 again, minus 16, close parentheses. It should equal 31. Let's see. Woo! We did it. All right, last one. You know, there's something we haven't had yet. I think this is it. Okay, on the right side, we have a 1/3 that we're going to need to distribute. How do I know it needs to be distributed? I see a number out front of my parentheses. Distribution is multiplication. So I have 1/3 of 9, which is 3, and 1/3 of negative 15, which is negative 5x. What do you notice? Negative 5x and negative 5x. Positive 3 and negative 3. No, they're both positive. I'm sorry. Positive 3, positive 3. They're the exact same. So if we go and continue to solve this, what's the opposite of minus 5x? It's plus 5x. Negative 5x plus 5x is 0. It's actually 0 on both sides. 3 equals 3. It sure does. 3 and 3 are the same thing. They are equal. This is what we call an infinite solution. It means any number will work in here. You can pick any number you want for x and put it substitution, and it will work. Thank you.